4 billion miles from the sun, where temperatures plunge to minus 230 degrees Celsius, there is liquid water right now. Not ice, not ancient traces, a living, breathing ocean, and it's been there since before the first cell divided on Earth. For decades, we assumed the outer solar system was a frozen graveyard, too cold, too distant, too dead. But Pluto just shattered that assumption. Its ocean isn't freezing, it's warming. And if an ocean can survive out there in the darkest corner of our solar system, what else is hiding in the ice? When New Horizons flew past Pluto in 2015, scientists expected a cratered snowball. Instead, they saw something impossible. A massive heart-shaped basin called Sputnik Planitia, 1,000 kilometers of smooth nitrogen ice with almost no craters. That's like finding a beach with no footprints after 4 billion years of storms. Craters tell time. Every world in the solar system collects them like scars, but Pluto's heart was fresh, young. Something was erasing the evidence. At first, researchers thought nitrogen ice might flow slowly like glaciers. That explained part of it, but the basin sat in exactly the wrong place. Sputnik Planitia is positioned almost perfectly opposite Pluto's largest moon, Charon. The odds of that happening by chance are nearly zero, unless something heavy was pulling it there. Heavy like water. Dense like an ocean hiding beneath the crust. But here's where it gets strange. That ocean should have frozen solid billions of years ago. Here's the problem. Pluto has almost no internal heat. It's tiny, smaller than Earth's moon. Whatever warmth it had from formation should have radiated away eons ago. So how do you keep an ocean liquid for 4 billion years without heat? You insulate it. Pluto's surface is covered in nitrogen ice. But beneath that lies a different layer, water ice mixed with compounds called clathrates. Think of clathrates like bubble wrap made of ice, with gas molecules trapped inside. This layer conducts heat 10 times worse than regular ice. It's essentially a cosmic thermos. The little heat Pluto does produce from radioactive decay in its core, uranium, thorium, potassium, gets trapped. It can't escape through the clathrate blanket. Over billions of years, that tiny trickle of warmth accumulated. Wait, this means the ocean isn't just surviving. New models show it might actually be getting warmer, growing, expanding upward toward the surface by perhaps 100 kilometers since Pluto formed, which leads to the part that most people never hear about. We've been looking for life in all the wrong places. For decades, the habitable zone meant one thing, the narrow band around a star where liquid water can exist on a surface. Earth sits in that zone. Mars grazes its edge. Everything beyond Jupiter seemed irrelevant. Pluto just moved the goalposts to the edge of the solar system. If a world this small, this cold, this far from any star can maintain liquid water for 4 billion years, the universe is absolutely flooded with potential oceans. There are trillions of Pluto-sized objects drifting between stars, rogue planets ejected from their systems, wandering through interstellar space with no sun at all. They could have oceans too. The same clathrate insulation. The same radioactive warmth. The same liquid water lasting billions of years in total darkness. Life doesn't need sunlight. It doesn't need a surface. It doesn't even need a star. It just needs time, chemistry, and liquid water. Pluto has had all three for longer than complex life has existed on Earth. So the real question is, does this change what we think is possible? Scientists aren't waiting to find out. Right now, mission concepts are being developed specifically for Pluto. The Persephone orbiter proposal would return to the dwarf planet and stay, mapping its surface, measuring its gravity field, searching for geysers that might vent ocean material into space. Europa Clipper launches soon, targeting Jupiter's moon. Dragonfly will land on Titan in 2034. Each mission tests technologies that could eventually reach Pluto. Ice-penetrating radar, mass spectrometers sensitive enough to detect amino acids, instruments that can taste an alien ocean without ever touching it. A team at the Southwest Research Institute is already running new thermal models, trying to predict exactly how thick Pluto's ice shell is. Some estimates say 30 kilometers, others say 300. The difference matters. It determines whether we could ever drill through. Researchers are losing sleep over ice chemistry, because if that ocean connects to the surface even occasionally, evidence might already be waiting on the ice. 4 billion miles away, beneath a sky where the sun looks like just another star, water moves in darkness. It's been there since Earth was molten rock, since the first oceans on our own world were still forming, and we almost missed it completely. The universe keeps hiding oceans in the last places we think to look, not beside stars, not on surfaces, but deep inside frozen worlds we dismissed as dead. If Pluto has an ocean, what about Eris, Makemake? The thousands of worlds we haven't even named yet. Here's the question. If we sent a probe to drill through Pluto's ice, what do you think we'd find? Sterile water or something stranger? Follow for more. We post every week.